Hello everybody, welcome to Blue Marble Science. Unbelievable! There is enough derp in this video for an army of stupid people. Warning! Severe facial and monitor damage alert is in effect. Get out those oven mitts. Get some more oven mitts. Push the monitors back out of punching range, and let's join this dumpster fire in progress. You know, usually I have to do something to make one of these videos, but in this case, I get to just sit back with you guys and listen. This is an exchange that took place between myself and Brian Leake on Jose JG's show. Shout out Jose JG Gonzalez, and a link to his channel will be in the description. So let's listen as Brian Leake and I have a bit of a disagreement over the difference between acceleration and the inverse square law. Anything we measure accelerates toward Earth at 9.8 meters per second. Okay? And I don't care what it is, if you drop it 10 seconds later, it will be moving at 98 meters per second. Period. That's the way it works.
Oh my God, you just fucked your whole debate, dude.
You think I did?
Oh yeah. So 10 seconds later, okay, so answer me this. Let's just make it simple and say 9 meters per second squared. No tricks. Okay, if something's falling at 9 meters per second squared, real quick, 9 meters per second squared. After 3 seconds, how many meters per second is it moving? Go ahead. Let's see if you understand the inverse square law. After 3 seconds, how fast is it moving? Go ahead.
27 meters per second.
Wrong. Try again.
Really? No. Right. You need to try again.
Motherfucker. You said 98.
What are you doing, Brian?
After 10 seconds. You don't understand inverse square law, Blue. I'm sorry to rant, but you just killed your whole debate. See, let me say, Coulomb's law, the reason I said...
Wait. Not Coulomb's law. Let's stick with gravitation.
Everybody who's listening, who's looking it up, knows it's not 27, dude. Listen,
yes,
squared means you square the second. You said
no,
square the second, but you couldn't do the simple math. Okay?
Brian,
one more guess.
Brian, you really need to back up. You're going to get hurt on this one.
No, dude. You just we're ending with some.
Well, he can't say I didn't warn him.
Heat. We're ending with some heat. But let me get out one more point. Yeah, my denial.
Something with a boom.
But the difference between we could easily have asserted Coulomb's law to gravity. All we had to do was appoint negative density. If we'd have said helium is negative and certain amounts and certain things are negative, that's what I meant when I said that the only difference between Newton's law and Coulomb's law is that mass is always a positive. So all we had to do, and the math would have worked out just the same, Blue. And to answer your question, it is 81 meters per second after 3 seconds, because 3 seconds times 3 seconds is 9 seconds, times 9 meters is 81. So after 3 seconds, you're already 81 meters per second, which is way past terminal velocity. So y'all say things accelerate, but in reality, at 2 seconds, everything's as fast as it's going to go. And it's starting at 0. So, of course, it's going to accelerate.
Okay.
So, so
Brian,
all respect, no Blue. All respect, buddy.
Okay, Brian.
Just let me stop you for 1 second.
Go brush up on your math, man. That's all.
No. You don't understand the equation. You don't understand the application of the equation. Acceleration is, let's drop the 9.8.
When you're wrong,
Brian, hold back. Brian, please hold back.
Humble yourself.
Brian, please hold back.
No need insulting. I'm not trying to insult you. Don't do it to me.
No, I'm not. I'm just saying if I'm wrong, I'm gonna say
Brian, I'm gonna mute you. Brian, I muted you. Please stay on mute. Let Blue address the point.
It works like this, Brian. Let's say let's make the math real easy to do in our heads, and we'll use 10 meters per second. That is what we say is 10 meters per second squared. It's 10 meters per second. Now, when you multiply that acceleration times 3 seconds, one of the seconds on the bottom goes away, the seconds on the top go away, and you're left with what? Meters per second.
I'm biting my fucking tongue, audience.
A velocity. That is how it works. If the acceleration of gravity were 10 meters per second, at the end of 10 seconds, it would be traveling at a velocity of 100 meters per second. That's the way it works. I'm sorry, but you're just wrong about it.
That's on a slope, dude. No wonder you think the Earth is a perfect globe, because you think 9.8 meters per second squared is on a slope. So you think I mean, I want to say 8 inches per mile squared. You think 10 miles times 10 miles equals only 10 miles times 8 is 80. So you think after 10 miles it's only 80 inches?
Brian.
Well, in reality, an inverse square law works like this. If you're squaring the seconds, then you square the seconds. So 3 seconds means 3 times 3. Oh shit! I waited. And what rolled up?
Hear me out, Brian.
Anyway, he's wrong on this, Jose.
Everybody is saying that you're wrong. Even flat earthers in the chat. Go ahead, Blue. Let's Blue.
Dude, 3 times 3 is 9.
Okay. You spoke your piece. Yeah. You muted again, Brian, because you got hot mic. So Blue, go ahead.
That's not the inverse square law, Brian. That is an acceleration. That's the way accelerations are stated. It's
So what do you mean by squaring the second?
Wow.
You don't mean squaring it?
No. An acceleration looks that way. It can be written that way, but it can also be written 9 or 10 meters per second per second. That's the same thing. Mathematically, that is identical, but it's an acceleration. It's not a squared function. It is simply an acceleration. An acceleration multiplied times time, simply time, will give you a velocity. In the first second, it has a velocity of 10 meters per second. In the second second, you add another 10 to it. That's 20. In the third second, you add another 10 to it. That's 30. That's how this works.
So why is it squared then?
It's it's per second per second.
Right, per second.
Hey guys,
Look,
5 more minutes.
Brian,
let me tell you this, because this is the important part. I'm gonna let you guys have the floor for 5 more minutes, and then we'll do a quick 1 minute final thoughts, and we'll open the panel. So I'm gonna mute myself for 5 minutes. Respect each other. By that I mean, Brian, please respect the not F-bombing, because you've been going a little off.
Okay, 9.8 meters per second. Okay, 1 second means it's going 9.8 meters per second. Okay, 2 seconds means it's going 39.2 meters per second, which means 42.86 yards, which equates to 154,296 feet, which is 87.66 meters per second. Okay, 3 seconds means 3 seconds squared. 3 times 3, 3 squared. Second squared, 3 squared is 9. 9 times 9.8 is 88.2. Okay, so after 3 seconds, it's going 96.45 yards. Converted to yards, okay, then that means 347,220 feet, which converts back to meters, which means 197.28 after 3 seconds. Not 100 if it's 10, but 197.28 meters. I stopped after 2 decimal points. Okay, just, I was doing that just to figure out the terminal velocity, which it's right around 2 seconds for a person. And I pretty much stopped. I went up to like 6 seconds, but all I had to do was look up terminal velocity. And that guy earlier said that terminal velocity is in like 10 seconds at the end of the show earlier.
Brian, I meant 5 minutes for both of you to have a free flow discussion, not you
monologue
for 5 minutes.
Wrong. I told him he was wrong. I didn't mean no disrespect, but it doesn't take 10 seconds to hit terminal velocity, and you don't understand the inverse square law, and you will hear about it. But I still love you, Blue. I love you, Jose. Go
ahead. I'm actually lost for words, Brian.
Don't make me call you a dumbass.
Well, I would rather you didn't, but if you feel so inclined, go right ahead. You're going to find out that you're really, really badly out of whack here, the way you're trying to do that calculation. That's not how it works. You multiply an acceleration times a time to get a velocity. That is as well known as anything is in physics. And I'm just going to let it go at that, okay?
Okay. Well, we could just say 9.8 meters per second, and we don't have to square it.
Because
9.8 meters per second means in 3 seconds, that's 27. That was your second answer, was 27. That still ain't right, but, so
no, that's not my second answer. You can't keep changing the acceleration. If it's 9 meters, if you're going to use 9 meters per second, then at the end of 3 seconds, it is 27 meters per second. Ta-da! If you're going to use 10 meters per second,
get it now, dude.
After 3 seconds. It
Think
is
of what you just said, dude.
30 meters per second.
Think of what you just said. Go back to the beginning. Think of what you just said. Eureka.
What did I say?
Checkmate. Checkmate, motherfucker.
What did I say? What do you think I said?
You
tell me what
you have
did
to
I
square
say?
the second. You said that after 1
No.
meter, it's not going 9.8 meters. So you have to add to it. See,
No, I didn't say anything of the sort.
No,
Where are you getting that from?
I twisted it because that's what you meant.
No, that's not what I meant.
So what's your final answer on things going through?
Which acceleration do you want to use? Pick one. 9, 10, 9.8.
Let's just
What do
use
you want?
9. Let's use 9 for the crowd's sake.
Okay, 9.
You still stick to 27?
Absolutely.
Okay. All right. Well, we'll end it with that, man. And I think 9 meters per second without it being squared, 3 seconds is 27. What's the point in squaring it?
It isn't squared, Brian.
Square
We're not talking about
growing exponentially.
Brian, we're not talking about the inverse square law.
We're
The acceleration.
talking exactly about the inverse square law.
No, we're not.
Way out for you. I'll give you that.
I'm not. I'm sorry. No, you're not.
What are
We're
you
talking about? We're talking about an acceleration, which is a rate of change of velocity.
Right, not a slope, an acceleration.
It's a rate of change.
Even 45-degree angle was what you would get if you did not square it. You know, as far as rate goes, you would not get a nice little 45-degree angle of acceleration. That's all you get is if you didn't square it, is a nice 45-degree slope of acceleration. I mean, of movement. But accelerating, it accelerates by definition. You know, so when you square it, it starts accelerating, so it gets faster and faster exponentially. And you'll see once we get over this. But like I said, man, I just want you to come back and admit, humble yourself one time. I'll say you taught me shit tonight, Blue. But, but humble yourself one time. We all got to see it, man. If I'm wrong, I'll humble myself.
Well, you're going to need to because you're wrong.
Guys,
why won't you
Brian,
consider you might be wrong?
Brian and Blue, it's
right,
been a little over an hour. Thank you very much. I mean, I don't think we arrived to any
Hey,
conclusion.
thanks for watching. We're going to leave Brian now in his quest to try to sort out the difference between an acceleration and the inverse square law. I don't have a good feeling about this. Hey, I hope you guys enjoyed it. Don't forget to hit the like and subscribe buttons down there. Tickle that little bell if you want notifications. And a special shout out to the patrons and the PayPal donations that have helped us so much with the Cavendish project. And with that, I guess we'll see you guys on the next one. Hey, Gladys. We're out of here.